Hello and welcome back again to the Code Maven Programming Bootcamp. My name is Gabor Szabó. Hi Nora.
Hi.
Welcome back. In this video, we are going to talk about dictionaries. This is the third major data structure in Python. Let me share you the screen. Right. And we are going to talk about dictionaries. So this is the slide that the slide series. But before that, I would like to show you something that we discussed earlier and that I didn't know how to show it. And let me do that. So what we were talking about is mapping the .py extension to Python and how to do that. So I just have here one of the Python scripts, .py, and it's if I right click on it, I can say open with, and here normally, I mean, I already have it. I already have Python here because I already did it once, but normally you wouldn't have. So now if I double click on it, oh, it already mapped it anyway. Okay. So I tried not to have it earlier, but I do have it here. So let's remove that association. Can I remove it? I don't know how to remove it. Okay, so I just wanted to show you something, and apparently I can't really show because I can't get rid of it now. Earlier I couldn't make how to make it. Now I can't get rid of it. Anyway, so if you double click on a .py file and it doesn't start you Python, doesn't start your program, then what you can do is you right click on the file, and then you can, first of all, you can say open with, and then search for the application, search for Python. And that's what I didn't know how to do it. And if you would like to make the mapping that it will always happen, well, apparently it does. If you do it once, that it maps already, I don't know. But if it doesn't work, then you can click on the properties and opens with. You can click on change, and here you can find the actual application. Now, how can you find Python exe is something that I didn't remember earlier, or I didn't know how to do it. So I'm switching to the Anaconda prompt, and I type in where, and I say Python. So where is a command on Windows specifically. On Linux, it would be which, the same idea. And it gives you the location or locations where this program, this executable can be found. It gives me two locations. One of them is the Anaconda Python, Anaconda 3. That's what we are actually using. The other one is, I'm not really sure what is that. I think it's some kind of Python that Microsoft can provide or provides. It's unclear to me. But in any case, this Python is the first one. So if I type in now Python -V, then this Python, the first one, will run. And this is what the one we are looking for. So here I know that I can see that it's C Gabor Anaconda 3 Python.exe. And that's what I use when I go back, and when I would like to change the open with, I go and click on more apps, and then I scroll down and then say look for another app on this computer. And then here in the file explorer, I have to find that location. So it's local. What was that, Gabor? Anaconda 3, and here the Python exe. Okay, and there is also a Python W exe that will be useful once you decide that you would like to create the GUI-based applications, and that's what you would like to use. But for now, it's a Python exe, and then I click open, and this created now the mapping. If I already had it, but this creates the mapping. Apply, okay, and now if I go and double click on a file, then it runs and already runs Python, and I can type in my name, and that's the problem that you asked what to do with, and that once the program ends, it closes this window. And I'm not sure if you can actually change that, maybe there is, and I don't know if you can change that except of having something in the code that will wait for it. Okay, so that's what I just wanted to show, because we discussed it and I didn't know how to show this back then. Okay, so dictionaries. In other languages, this same construct is called a hash, or sometimes it's a Mapcar or map thing. Basically, a dictionary is just is probably the most non-programmer friendly name of this whole thing. So what is a dictionary? Is some place where you look up words, and you have used these unique words, and each unique word can have a value, or maybe a list of values, multiple values, but they're something that you can look up like in a dictionary. Okay, so if we go into the slides, behind the scene, it's unordered key value pairs. So it's a data structure in a way similar to lists, where you can store data, but instead of having a list of values one after the other, we have key value pairs. And the keys are immutable, so they can be numbers or strings or tuples, anything that's immutable. And the values can be anything. So in the value, you can have a number or a string or a list or another dictionary as the value, so you can have anything. When would you use the dictionaries? Any case, anytime when you need a mapping. So let's say you have to store in the computer, in the memory of the computer, a mapping from ID number to a name, or some kind of an object, let's say, I don't know, fruits, and how many you have, okay? Or you might have something and it has features. Let's say a person has a name and an email address and an address and all kind of features. And then you can represent this with a dictionary where the features are the keys and the values are the respective values. Okay, so all kind of these things you can have. Attributes and attribute value. And let's have a look at these dictionaries, how they look syntactically. So the default, if I want to create an empty dictionary, just a pair of curly braces, that creates an empty dictionary. And now this variable user is an empty dictionary. I can put in a key value pair this way. So I say user, the name, the key is name, and the value is foobar. And if I now print out the user, so the dictionary, the whole dictionary, this is what I'll see. So this is how it looks like when I just print it out. Okay, I can add another key with another value. And then I can print out again user. And now this time I'm getting this user key value pairs. One thing that is important to remember, that the order is not defined. So even though recent versions of Python have keeps some kind of an insertion order or something, it doesn't really, I wouldn't recommend anyone to think about it as having an order. So when you print it out, the name and the email can be, I mean, the pairs could be in different order when you print it out. But it's always key value. Okay, so this is how we put in values, keys and values. This is how we fetch the value of a given key. So I have the key name, and now I have copied the value of that key into this variable, the name. At the end, this thing is just a regular value, just as if you had a single variable. The thing is that you don't have to put here the string. You can put a variable there as well. So now I have a variable called field, just any name, which has the key in it, and then I can access the value using that. So it's dynamic. And what happens if I put in the name key a different value? Well, it replaces. So just like if you assign to the same variable some new value, it will just replace the original value. Okay, and now this is what I have, edit PF here. Okay, nothing special in that. Okay, so now we know how to access the value if we know the key, but sometimes we don't know what are the keys. So for example, here I have a dictionary, and I can print out the whole dictionary, but I can also fetch the list of keys. So I can say dictionary.keys, parentheses, and this is a function that will return a list, which is the list of the keys that are in the dictionary. And now once I know I have all the list of the keys, I can iterate over them, right? So this is what we have in the next slide. We have the dictionary. We fetch the keys using the keys method, and then we iterate over them. So K is going to be the key on every iteration. So this will print out L name and F name because of that. And using that key, I can also access the actual value. So this is how I would access the actual value. So in this example, I'm printing out the key, L name, and the appropriate and the right value for it. Right. There is also another method called items that allow us to go over the pairs. So instead of going over the keys and then fetching somehow the value, we can call people, in this case, people.items. And then in the for loop, I put two variables. And the first one will get the key, and the second one will get the value from the dictionary. Okay, so that way instead of accessing the content, I already have two variables that probably have meaningful names. Yeah, this is the same as just now. Instead of two variables, I put a single variable, but this is a tuple now with two elements. Similarly to the keys, I also have a values function that can just get the list of all the values. But because it's a one-way mapping, from the value I can't get back the key. So the keys are unique, the values are not, or not necessarily. Okay, what happens if I try to access a key that doesn't exist? So here I have a dictionary. I print out the content of fname, the value of fname, that works fine. And then try to print out the content of email, the value of email, but there is no email. So I get the foo, I get the value, the first value, but the next one gets me a key error. So what can we do? So we won't get this exception. There are two things that we can do. One of them is to call the get function. So instead of accessing what we had here, is that a user and square bracket key. Instead of that, we have here dictionary dot get, and then it's a function, so it gets the name of the key as a parameter. And this will return the value, or if the value doesn't exist, it will return none, instead of raising an exception. And then you can even put a default value in there. So in this case, because email doesn't exist, like this one, so address and email, they neither exist. Okay, so wait a second. So address exists, but the value of it is none. Email doesn't exist. So in both cases, what we get back none. But if I put here a default value, the second parameter, then the get function, get method will return that value instead of none. So that's in case you think that the key might not exist or the value might be none. Okay. There is another way, just like with lists, you can use the in operator.
Wait, just a second. Can you go back to the previous slide? So here, if you typed user.get and then address and then 42, would it still give 42?
I think so. I hope so. Let's
Okay.
check it. Let's make sure that that's right. So it's called getKey.py, right? So in the dictionary examples, dictionary, and it's called getKey.py. And it is, and you would like to know if printing out, let's make it 23 and address, right? This is what you asked. So dictionaries, and it's get key. Oops, that's the output of it. Okay, so it gets you none.
Right, because it actually has a value of none.
Right. Mm-hmm.
Okay, yeah, that's all I wanted to check.
Okay, good.
Thank you.
Good that you're asking. Okay, where are the slides here? Okay. Does the key exist? So that's the other next thing. So we can, instead of just calling get, we could actually ask with the in operator if the key exists. So we ask some string in some dictionary, and it's going to be true because fname exists, and it's going to be false because email doesn't exist. And even if I ask foo, which is actually a value, it will say false because it only checks the keys. Okay.
So how can you search between the values, for instance?
You can't.
Can you do that?
So the whole idea here is that if you need to, so it's a lookup table, like in a dictionary. If you'd like to, would like to translate from one language to the other, then you can easily do that. If you'd like to translate in a different direction, then you need the other dictionary. So you need to have a different dictionary for that.
Right.
So it's basically the same. You can hold both in the memory, but then it will double the amount of memory you need. Okay, so yeah, so here's an example how you would use this. So for example, you go over some strings, and then you check if that string is a key in this dictionary, and if it is, then you print out something. Okay. Now, if you'd like to know if a value exists, you can do that, but in order to do that, you have to actually have to fetch all the values. And here is a big issue of the whole thing. Why are these dictionaries are really important? It's easier also to program in them, but it's also they are way faster than lists in certain operations. So if I would like to check if a value is in a list, Python has to go over all the list. So if I have 1 million elements, it might have 1 million operations till it finds out, no, it's not there. Okay. In dictionaries, they work in a way that Python doesn't have to go over all the keys. It can go directly to the key. Okay. And I can explain it. The easiest way probably to explain it is that it in a way it's similar how dictionaries really work. So just so think about it that you have a list of words, okay, and just on a piece of paper. Now, if you need to find one word, then you have to go over the whole list, right? So you have 1,000 words. That's 1,000 checks. Now, what if you prepare it before that you put them in a dictionary? So you have these blocks of those words that start with the letter A, the words that start with the letter B, and so on. Assuming that we have 24 letters, and they are the words are distributed the same way, I mean, uniformly among them, then let's say, let's assume 25 because it's easier to divide by 25. Then it's the 1,000 divided by 25. I don't know what is that, 40, right? So in each one of them, you have only 40 elements. So now it's super easy to get to this one of these blocks. And inside, you only have to check 40 elements. So it's much faster. Now, if we had a dictionary that uses the first 2 letters of each word, then we already have 24 times 24 possibilities. Again, if the distribution is correct, is uniform, so everything is the same, the possibility, then you have 1 or 2 elements in each of these, what we call buckets. Okay, boxes, whatever. So if now I have to go, then it's very easy to look up the first 2 letters. I know where to go, and inside I immediately find it because it's either the single one that's there or maybe the other one that I was looking for. Okay, and this thing that I take words or strings in general or values in even more general and map them to some location in a memory in a very fast way is called hashing. That's why in some languages this whole concept is called hash. Okay, because behind the scenes that's how it works. But for us, it has this wrapper around it. We don't have to care about all this mapping behind the scenes. For us, it's a unique mapping, but it's very fast. So it's basically unless we are super unlucky, okay, because it can happen. Unless we are super unlucky, the speed of finding an element in a dictionary doesn't change with the size of the dictionary. So if you remember, we talked about complexity at in an earlier session, where we said that a function of the number of elements of the input, the length of the input. So if we use a list, then in order to find an element is O(n). So it's the same, it grows linearly, whatever, with the length, with the number of elements. With using dictionaries or hashes behind the scene, it doesn't matter how many elements you have. Accessing the element is the same. So now if we get back to the actual slide, when I look up if a key is in a dictionary, that's O of 1. It's immediate. If I need to look up if a value is in if something is one of the values, then first I need to fetch all the values, and then I have to go over, or Python has to go over all the values. So now it depends on the number of key value pairs, or number of values. Okay. We'll talk a little bit more about this, the speeds or the complexity thing. Deleting a key, so you have a dictionary, you can get rid of one of the keys by saying, in two ways actually. You can say del or del, and then this construct, and this will remove the key F name from this dictionary, and obviously the values get lost because we don't have a key to it. So that's one way. The other way is to use pop. This time pop needs to have a parameter, and this is the key that's going to be removed. But in addition to the value being removed, or the key being removed, the value is returned here. Okay, so sometimes what we do is we have a dictionary, we go over the keys in some way, and we remove the key, and then, but we need to process the value to do something with it. So it's either we fetch the value, like I did here. So I fetch the value, and then I delete the key, and then I have the value. Okay, or
so deleting the key also removes the value, right?
Yes. because you don't have access to it.
Yeah, okay.
Okay. And the pop thing is, it also removes the key and the value, but it puts the value here in this, so it returns the value. And it's useful, sometimes it's useful when you need then to process the value. Sometimes you just want to get rid of it, sometimes you also want to do something with it. Okay, so one of the examples I mentioned is that a dictionary can hold, let's say, information about a person, okay, attributes, names, and attribute names and attribute values. So what if you would like to have a list of people, or list of objects or whatever, doesn't matter. So you can create easily a list of dictionaries. And here, in this example, we have a list. I know it's a list because it's square brackets here. And then it has two elements, one dictionary and another dictionary. Okay, the first dictionary is relatively simple, it's just key value, key value. In the second dictionary, I have different keys, so I have the same name and email, okay, but I also have an address, and then also have children, but the value of the children is itself a list. Okay, and you can go any depths in this, so you can represent any complex data structure, and it doesn't need any symmetry. So I mean, the keys are different here and here. This one has an additional level it doesn't have, so it's totally flexible. Okay, and then once I have this data structure, I can access the elements, so I can print out the whole thing, which it's here. It looks like this, not that readable. I mean, actually, it's quite readable. You just have to focus. You know, I mean, you can see it. It's a list, and then it's the same, just one line. But you can also access, so it's like this. So say people element 0, so it's the first element in the list. And then in there is a dictionary with a key name. So this is the dictionary key, and this is the value, foo bar. And that's why it's foo bar. Okay, and in the second case, this is element 1, so this dictionary. Then it has children, so this one. And then it has 0, so it's alpha. And that's it. And okay, so this is just some extra craziness using a couple of these advanced features. What we do here is print out the names of each of the elements, each of the dictionaries. So the foo bar and the Cook's bar, whatever it is. I ran out of words. Okay, I should get back to the vegetables and the planets, I guess. So what we have here is that, first of all, we have a map. Okay, so you remember the map, what it does, it gets a function and an iterable, something to iterate over, and then runs the function on each element, and whatever the function returns, that's the map sort of collects. So you already saw lambda. So in this case, I just used the variable name p, because person, I guess, doesn't matter. And then in there, so this p is going to represent every time one person from the list, from this list, one element from the people list. And the p square bracket name is this value all the time. So now the map actually returns me something, an iterator that can go over the names, the values of the names, and then the list function just converts them into a real list. And then I just print it out, and then you get the list.
With the lambda bit, so here you didn't have to say key equals lambda.
Right.
Why was that?
Because I actually don't know. So when we learn functions, when we're going to learn functions, you will see that you can pass to the functions parameters based on by location and
Right.
using names.
Yeah.
And in this case, I was using the location. So
Right.
the first
Okay.
element is going to be lambda, and the second element, first element is a function, which is the lambda, and the second element is the list. And in the sort case, I used the naming, the style that I used the name. And
Yeah. Okay.
and the reason I use that is because I got used to this way. And that sort of that's, I guess, is the customary way. But if I really wanted, I would probably can look up what are the names of the variables of map. And I could actually probably change here even the order and use something. It might not be key. I don't know what is the name of the parameter. Okay. And also in the sort, I could probably figure out what is the actually order of the parameters, and then I wouldn't use the word key. It's just,
Right.
I guess when I learned it, this is how I learned it, and I never thought that to change it because sort of.
It was easy that way.
Yeah, this is how it is, and I never questioned. I don't question authority. Yeah.
Sorry about that.
Okay, so very good point. Okay. Wow, share dictionary. What are we doing here? Some extra slides here that I probably should skip now. Right, let's skip this slide. I come back later on. I think we don't need that here. Here we can you can see an example where I just show that you can use a tuple as a key because it's an immutable. And I actually never used it, but I know people who do. Okay, so I'm not used to to this kind of construct, but you can definitely use a tuple when you have basically multiple values to be used for a key. Then it can be really useful. And another example where we use numbers as the keys. Okay, because numbers are also immutable. Right, and now this one. So here we have scores, dictionary, key value pairs. So far, okay. If I print them out, I get them in basically random order. Or let's see this random order. I can call sorted on this. Okay, so right, so the general thing that people ask many times, how can I sort a dictionary? Okay, and the fact that you can't sort a dictionary. You can either sort the keys or you can sort the values, but you can't really sort the dictionary. Okay, well, anyhow, people use this expression, I would like to sort the dictionary. Okay, so the question, what do they mean? So if I run sorted on the dictionary, I get the keys apparently sorted. Okay, and then I can go over them and print out key value pairs. Okay, but what if I would like to print out the values sorted? So the immediate thing that people would do is, okay, let's take out all the values using the values function and call sorted on them. And then now we have the numbers sorted. Nice. But how can now combine the two? How can we know which number is related to which word? And maybe I should change this example so it's going to be obvious why there is a problem. But if I had the same number twice, here I wouldn't know which one is which and how to map it. So what we do instead of that is that we use the sorted. We're going to sort actually the keys of the dictionary. So I could have used here dot keys as well, but it immediately gives the keys. And then the key function is quite similar to what we had with the tuples actually, right? And so the sorting function is again a lambda that gets a value all the time. This x is the key. Okay, so maybe I have to clean it up. So when you sort, let's say, a bunch of people, you have the key is the actual person, and the value is, let's say, the height of the person. Okay, so but what you sort, even if I say even if I tell you sort these people according to height, that's what I'm saying. I am saying to you sort the people, not the heights. Okay, so here is what we do is we are going to sort the keys, but according to the value. And then we can print out both the key and the value if you want, but we have to sort the keys. That's the usual thing that we do. So we sort the keys here, and I probably should put dot keys to be make it clearer. But we say that every time we compare a key, so X is going to be one of the keys now, just fetch the value from the dictionary and then compare those values. So this one is going to sort the names again, but this time it will compare the values, so the values from this dictionary. And if I print out, then you can see that, well, it's increasing order. You could also say the reverse here, if you want to reverse through, and that it would do. And then let's skip this example because it's even more advanced and it's not really necessary now. Okay, but this idea of sorting, so just again to repeat myself, so when we say sort a dictionary, or many people when they say sort a dictionary, but in fact they mean that they sort the keys, and sometimes it's based on the value on what is the value. Let's skip this one. It's just a leftover from an earlier one. We can also basically skip these slides. Python allows us to keep the insertion order, or actually newer versions of Python keep the insertion order, and then we have ways to reorder the dictionary. I guess I need to move these slides to some advanced part because this is really not necessary here. Yeah, let's skip these ones. Okay, so any questions here?
Yeah, I'm a bit confused with this order bit actually. So for now, you said that like every time we print stuff out, it prints them out in a random order, right?
Yes.
Seemingly random order anyway.
Yes, that's
but if you say that like more like newer Pythons keep the order of
right. So yes, so
insertion.
So I try to simplify it or lied or whatever you can call it. The thing is that I personally don't understand why it's useful to keep the insertion order in general. Okay, so I would just assume that the returned order is random. Even though if we really look at what happens is that the insertion that Python starting from 3.7, so version 3.7, it keeps the insertion order. Okay, and I'm not used to this. Okay, I'm rather new. I think now we are 3.8, so it's about a year or 2 years old. I think this feature. I'm not sure. No, I don't know what is the value of keeping the insertion order. I mean, I do know that, and I don't know what is really the price. Maybe there is no price. Okay, I guess if there was a real price for this, then maybe Python wouldn't do it. I don't know. So I'm sure there is something. I mean, something somewhere behind the scenes must keep the order. Because normally a hashing algorithm, so what's behind the scene, doesn't know about the order, doesn't care about the order. Okay?
Right, yeah.
What I would say is that even though in newer versions you already get the same order again and again, I wouldn't assume it, partially because your code might run on older versions of Python, and partially because I don't know. There's no other reason, okay, actually not to assume that.
Right, okay, thank you.
Actually, I wanted to say a couple of more things about the word hashing. So even though it's not directly connected to dictionaries, so there is this, there are all kind of these what we call hashing algorithms, very well-known hashing algorithms. One of them is called MD5, the other one is called SHA1 or SHA1 or all kind of numbers, so depending on their number of bits they use, doesn't really matter for now. And one of the things that they can be really used really nicely is, for example, comparing files. So if you take a file and you calculate, which is just a long string, okay, and you calculate its MD5 hash, which is, I think, only 40 bytes, then if you take this and take another file somewhere else and calculate the MD5, then if the two MD files are the same, then you can be reasonably sure that the two files are also the same. Because, and it's even more so with SHA1. I mean, even though theoretically there could be collision, after all, this is shorter string, that one is a longer string. But there are some super computations that I'm not familiar with that show that the likeliness of this is something in a couple of billion years to happen, that you will encounter something that's exactly, that computes to the same SHA one, but is actually different content. So that's just an interesting behind the scenes thing. And just one more explanation before, actually, do you have any more questions?
No, I don't think so for now.
Before we go over the exercises, so this whole idea of dictionaries versus lists. So just keep in mind that, I mean, there are different places where you would use a list. So you would use a list where you have something ordered, one after the other. You would use a dictionary if you have some kind of a mapping thing, usually. And you also can keep in memory, keep in mind that the speed. So finding an element in a dictionary is immediate, or O of 1, and finding an element in a list is O of n, so the number of elements. Okay, so let's go over quickly the exercises. So the first one is probably familiar already, maybe not exactly like this. So we have a string like this, and count how many times each character appears. Just like we counted digits, do the same with characters. Okay, and what was this? Okay, we can also do it for characters in a file. Okay, so that's like that, even better. Then count words. Okay, I think I gave this exercise already in the list chapter.
Yeah, we had this before.
Yeah, so now that you know dictionaries, take that one and try to improve it. Okay, so you have the words, and tell me just how many times each word appears. And then think about it, that it could be anything. So it could be DNAs or just any sequences, and then you count how many each appears or whatever. I'm just using words here. Same thing, just take from this file, okay? And this is again more or less similar. So do you know what is a web server?
I mean, I have an idea, but it's probably not very detailed and not very good. So
Yeah, so
please tell me.
when you use your browser to visit the website, on the other side, there is a program which is, the general name of it is a web server that serves you the pages. Okay, and one of them is called Apache because it was full of patches. And it started it, but actually each one of them has this, that every time you visit that site, it will save in a log file your address, your IP address. So that's the address of your computer, the date when you asked for something, what file exactly, what page you asked. And I removed most of the stuff, but it also contains what browser you use and a lot of details, what computer you have and so on. But in this case, what I'm interested in, so this is just a snippet of such a file. What I'm saying, what the interesting thing here is that there are these IP addresses, so the addresses of computers. So prepare a report that's saying how many times, how many lines you encountered per each IP address. In the end, is the same. It's just combining somehow you parse, how you extract the strings. So yeah, let me. In this one, I gave you the strings to count. In this one, I didn't give you the strings, but you could easily get the string just by cutting up the text. In this one, you have to extract the strings in a slightly different way. But in the end, they are all the same thing, just counting strings. You have we went over this,
Yeah.
with the tuples, and also, so this is the same exercise now that you know dictionaries.
Okay.
Oh, something with DNAs. Okay, now you really find out that I have no clue. So you have a sequence here with all kind of random letters. Okay, some of them meaningful, some of them are just there to, I don't know, to mark something. And please create a report like this. So count how many times each one of you have, what is the percentage, and so on. Okay, this one, wow. You'll read it and you might understand it. I don't remember anymore. Involves all kind of interesting things, and then you can explain it to me. Okay.
All right.
And you can tell me what's incorrect with the exercise. A list of dictionaries. Okay, so you have a file that looks like this, which is a CSV file. Okay, but we don't need to know that much. The whole point is that you have these fields separated by commas, and then each one of them. So it's basically like an Excel file, right? Fields and rows and fields. You just this is not aligned nicely, but you know that the comma is separating them. Okay, and create a list called people, where each person is stored in a dictionary. The information about each person is stored in a dictionary that has that the fields are the words in the first line of the column, of each column, and the value is the current line, is the current value. So if I access people row number 1 F name, that's gonna be Eric.
So you actually want us to order it as well? Because here the first would, oh yeah, okay. Right.
Okay.
So just leave them in the same order.
Yes. Okay. And these are the Monty Pythons. Okay. Okay, now do the same, but actually we have here a tuple, so that now the people is a dictionary that the keys are this tuple. So the key of this tuple is the name using the F name L name syntax. Okay, and then it has the value itself is a small dictionary that has keys and so on. Okay.
All right.
Oh, last one. Age limit with dictionaries. I don't remember. I think I added this exercise to one of the previous chapters after you did the exercise. So I added an exercise that you would, the program would ask the user what country is the user in and what is their age, and tell if they are above the drinking age or not. Okay, absolutely useful program. Yes, I know. So there's a link to the Wikipedia page of saying which country has which drinking age. And then, yeah, so you can store the information in a dictionary and then use that. Okay, so plenty of exercises. Enjoy yourself.
Thank you.
Any questions? Anything?
Not for now. I'm sure I'm gonna have a couple after doing the exercises, but we'll get to that then.
Okay. So, okay, so see you next time. See you next video after you do the other exercises. Bye-bye.
All right. See you.